Hi girls, this is Miss Page here. Happy Wednesday. Today is April 22nd and I'm going to do our math lesson with us. Before we get started on today's math, I want to show off work from our very own third grade scholar. She submitted this work to us after our lesson yesterday and I wanted to highlight it because today's lesson builds off the lesson you did yesterday. So you can see that she showed us eighths, ninths, thirteenths, and thousandths. Okay, and she put the fraction there that represents one whole. All right, so I have my 2 stars and a wish. The first star is that the work is clearly labeled, it's organized, and it's accurate. Okay, I can look at this work and I know exactly what she's thinking. It's labeled, very well organized, and it's accurate, which is even better. And the work was submitted in a timely manner, and it was one of the few work samples that were shared with us. Okay, we did not get many work samples sent to us. We're hoping they're all saved up in your file for when we return, but we'd love to see the work that you're submitting. So remember, easy, take a quick snapshot of it and send it in. This one was sent in nice and quickly after yesterday morning's lesson. And then my wish is to challenge yourself to create a realistic visual representation. Now, I know you're not going to draw the thousands, but challenge yourself to create a representation of maybe the eighths, the ninths, even the 13ths. Maybe create it in a number bond, or you can even create it in the fraction tiles like we've been looking at. Show what they are to equal the whole, or you could challenge yourself and put it on a number line. All right, let's get started on today's lesson.
Hi girls, today's learning target, you're on module 5, lesson 25, and our learning target is I can express whole number fractions on the number line when the unit interval is 1. Okay, so before we get started on our lesson, I want to review our numerator and our denominator, okay? Remember, our numerator is the number of parts being counted for, okay? The number of equal parts being counted for, that's the number on the top. Our number on the bottom, our denominator, is the total number of equal parts in the whole. So just in one whole, how many equal parts are in there? Even if you have multiple whole parts, when you're doing your denominator, you're just counting the number of equal parts in the one whole. Okay? And remember from yesterday's lesson, if the number on the top, the numerator, the number on the bottom, the denominator, are the same, that is equal to a whole. Okay, today we're going to look and see what happens when the number on the top gets bigger. I know Mr. Simon challenged you with that yesterday, but I'm going to go over some examples today. Okay, so let me remind you. Number on the top, the numerator is the number of equal parts being counted for. Denominator is number of equal parts in the one whole. Okay, let's have a look at today's lesson. All right, so up on my board here in the blues, what we'll start with, I have 3 wholes. 1, 2, 3. Okay? Each whole part is split into 1, 2, 3. So thirds. So the unit fraction for each equal part is 1/3. Okay? So I have 1/3, 1/3, and 1/3. Bring it a little closer so you can see it. I have 1/3, 1/3, and 1/3. That makes up just one whole. Okay? Again, 1/3, 1/3, 1/3. That and that gives me 2 wholes. Okay? And again, 1/3, 1/3, 1/3. If I have this, this, and this, I now have 3 wholes. So let's think about how we could put this on our number line. Now, if we have 0, that means I'm not counting any parts. So my numerator has to be 0. I'm not counting any. Okay? My denominator is the number of equal parts in the one whole. So if I just look at one whole, just one of them, I have 1, 2, 3 equal parts. Okay? So at 0 on the number line is 0/3. Okay? 1 on the number line. How can I label that? If I just have one whole, so that means I'm not looking at this one and I'm not looking at this one. They are removed because I'm not along there yet. I'm just at the 1. So I'm counting 1, 2, 3 parts. I have 3 parts in the whole. And I have 3 equal parts in the whole. Okay? So 1, whole is equal to 3/3. 1, 2, 3, 3/3. Okay? And there we go, that's a little clearer. Okay, so for 3/3, that's 1 whole. For 2 wholes, so this means I need to look at this whole and this whole part, not here, not the last one. It's removed. I'm only looking at 2. 1, 2. All right, so the number on the top tells me how many parts are being counted for. So I need to count 1, 2, 3, 4, 5, 6. I have 6 parts that I'm counting for in the 2 holes. The denominator on the bottom tells me the number of equal parts in one whole. So just one of these. One of these. I have 1, 2, 3 equal parts. So 2 is equivalent to 6/3. All right, let's have a look at 3. The whole number 3, I need to look at 1, 2, 3 wholes. Again, the number on top, number of parts I'm counting for. Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 parts are getting counted in all 3 holes. Number of equal parts in one hole, just one of these. 1, 2, 3. So 3, the whole number 3 is equivalent to 9/3. All right, let's have a look at our example in red. I have 1, 2, 3 holes. 0, 1, 2, 3. Again, I'm going to put them on our number line. But I need to know the unit fraction. So one whole that gets split into 2 equal parts, the unit fraction is, I hope you said 1/2. 1/2, 1/2. Okay? Same thing. I'm just now looking at the middle one. 1/2, 1/2. And this is also 1/2 and 1/2. Okay, number on top tells me number of parts being counted for. Number on bottom says total number of equal parts in a whole. In the one whole, there's 2 equal parts in the whole. Again, 0 on the number line means I'm not counting any parts, so I have 0 equal parts to be counted for. Number of equal parts in a whole, 1, 2 equal parts. So 0 on the top, 2 on the bottom is equivalent to 0. Okay, there's nothing there. If I'm just looking at just one whole, I have 1, 2 parts to count, and I have 2 equal parts in the one whole. 2/2. 2/2 is equivalent to 1 whole. 2 wholes, 1, 2 whole parts. I'm not looking at this one right now. It's not there. I only have 1, 2. Okay? 2 is equivalent to 1, 2, 3, 4 equal parts. And there's 1, 2 equal parts in the one whole. So 4/2 is equivalent to 2, or 4/2. That's another way we can say it. Okay? 3 whole parts. 1, 2, 3 wholes. All right? So that's equivalent to, count with me, 1, 2, 3, 4, 5, 6. 6 equal parts being counted for. Number of equal parts in just one whole is our denominator, so that is 2. This one whole part here, I have 1, 2 equal parts in there. All right? So, before you start on our lesson, I have a challenge for you. Challenge time. All right, I'll try and straighten up so you can see. Challenge time. Complete the blank boxes on the number line. So same thing. Here's 3 holes. 1, 2, 3 holes. You need to draw it with 1, 2, 3, 4, 5, 6 equal parts in all. All right. Draw this out. Draw your number line out. Pause the screen if you need to see it. All right. Fill out your number line just as we did in our lesson. And then make sure you send that in to us. Okay. Can't wait to see your work so then we can start showing them off on our videos. And then go ahead and get on to Zearn, complete all parts of Module 5, Lesson 25.